That's my bad. All right. So today, sorry, Fern. Yesterday the video would not record, and now it's working, and I don't know why, but that's okay. We are going to look at AP problem number 3 from the assignment last night, and let's rock it. Did everybody get a chance to try it before I just talk about it with everybody? Okay. So I'm not going to put that up here, but we have a colony of bacteria that grows at the following rate. So we're told that the rate of change of the bacteria, which is dB dt, is exactly equal to 6e to the 3t over 4. 6e to the power of 3t over 4. Okay. Well, we know that there are initially 8 grams of bacteria in the colony. How many grams will be present in 12 hours? So check that out. Initially, there's 8 grams in the colony. How would I write that down? At what time is what population? At 0, there's 8. And then there's another piece of information. They're saying, hey, how many will be present? And I'm just going to call it X right now, or T rather. I lied. How many will be present after 12 hours? So after 12 hours, what is this number? And I'm going to call this Y for now. And that's a question mark because we don't know it. That's what we're after. Everybody okay with it? All right. So help. I'm already stuck. Divide by T. So multiply by dt. Okay, so we get dB is equal to 6e to the 3t fourths dt. I agree with you. I like that step. What was the point of separating that dt, Sean? I almost agree with you. Sean says find the derivative. We're close. The integral. Let's do the other direction. But I think you have the right idea. I'm sure you have the right idea. Okay, so here we are. And here we are. Now what? Solve. Okay. What would you like to solve? Cool. So chat with your neighbors. I'm going to give you like 60 seconds. Try to come up with something to do because I know what I want to do, but I want you guys to also have suggestions. 60 seconds. I'll check back in with you as we're looking at this. My concern is that if I ask, what is this integral? Somebody's going to think it's 1. And I can totally see why that would be the case because if you just did the integral of dx, it's just x, right? Now, what variable is this? B. So if we do the 1 thing, and I'm okay with that, like we can think of it as 1. I'm trying to think of how I want to word this. Let's try to work this out. If I do the integral of 1 dx, and I'm sorry, this answer is going to come back. What is this integral? Is it just 1? X. What's this integral going to be then? And it's hard to tell, but it's b, right? That's what it is. Now, this is where I would prefer b of t because I think it makes it a little bit more clear, but it does make it ugly. If we're cool with this, is everybody on the same page that this is the same thing that happened? Okay, so now we get to do the easy side. Help. What do you want to do? Sure, I agree. Anything that can come out first? 6 comes out, and I don't really want to write e to the 3t over 4. There's something else I don't want to write, but I don't want to have to do a bunch of lines. Just say it again. E to the u? Huh. Well, what was u? 3t over 4. And then where do I go from here? No. I need to be able to say something here. I don't want a dt here. Do you guys agree with that? How do we get rid of it then? I want you to turn your notebooks back 2 pages and tell me anytime we found a u, what did we do? What do we do? Yeah, that was a hint. So I like the idea. I hate the word. It's not derive. Yeah, let's differentiate. We are going to find du is equal to 3/4 dt. And I'm going to go one more step just right here. That means that dt is du, or 4 du over 3. We are just u substituting, which maybe we just need to do a bunch of u substitution practice. For sure we do. I'm sure of it. Okay, what should I write here? Four-thirds du. Love it. Anything else come out? 4/3. So we're just going to work one line further. B is equal to, what's 6 times 4/3? 24 over 3, or 8. And now it's just the integral of e to the u du. Okay, well, that's pretty nice and chill. What's the integral of e to the u? E to the u. Okay, so easy. Notice integral symbol is still here, but we're about to do the integral. Here's the 8, and you said it was e to the u? And what's u this whole time? 3t over 4. And then anything else that I need? Indeed. That says 3t. I'm going to make that look a little bit nicer. Okay, from this point, we've done the hard part of it. I want you and your neighbors to finish this. Cool. I'm going to give you like 2 minutes. We have some points that we can use here, I think. I want you to solve this. That's a 4, not a 14. Cool. I'm going to give you guys a moment. Isn't it kind of cool that our initial value came out as an 8 naturally? Like, we don't even have to solve it now. We already had it. It spit itself out. It's kind of cool. I've said it before, and I'm sure I'll say it again, but I really like your kicks. What? No, you're okay. I just. Is that a B or an 8? So for this, I agree with you, but I don't think, remember that this is always our initial value right here. I think I already know it's 0.8. But we do need to find C, is what you're saying, right? Is that what you're doing? Okay, my bad. I misunderstood. Oh, it didn't even record. It didn't stop recording. I think you're okay. I couldn't tell. There was something wonky written, but I think if you rewrite it, you'll avoid it. All right. Talking through it, or do you just want me to work quietly while you guys are also working quietly? I think I'm going to make all of you guys move closer to me, because when you're farther away, it's easy to like hide and just awkwardly be silent, but the distance helps that be less awkward. We're all going to move. About 8 of you guys are going to migrate over here in a moment, just so you know. Cool. You can move too, Sean, if you need to. There's a whole lot of open desks in front of you. All right, let's solve it. What do? Help. Plug in what? Okay, so I'm going to plug an 8 in for, what am I plugging in 8 for? B, so 8, and I'm just going to switch color here while we're plugging in. We'll do it this way. 8 is equal to 8e to the 3t over 4 plus, ooh, what did I do wrong? What's t? 0 over 4 still, plus c. What do you want to do? Help me solve. So 8 equals, let's see, that's 1, right? 8 plus c. And what's c here? Okay, well, that worked out nicely. So it doesn't change anything. I'm cool with that. Okay, so now we know that this term right here is 0, and we don't even need to write it. Are we all agreed? So what's a real model that we can use to predict this in? Ooh, we need b of 12. And this is why I don't like that it wasn't b of t. But you're right, we need b of 12. Equals 8e to the 3 times, what am I plugging in here? 12 over 4, and I'm not even going to write the plus 0. Okay, well, 36 over 4. So 8e to the 9. which if I look at these answers, hey, look at that. It is delta, and that is exactly the answer that we need. Cool. Where did you guys go wrong? Or did you not? Did anybody get this problem right? And you did everything exactly like I did? Anybody start the same way and make little mistakes? I'd love to know the little mistakes if you guys can share them, if you're willing to. Yeah, I'm okay with that. Do we need another day of these, seemingly? Okay. We'll come back to 2 here in a minute. I want to do a much more fun problem. Cool. Here's the deal. I don't care if you do it on your worksheet. I don't care if you do it in your notes. I'll check the worksheet to make sure that you've done it. I'm not checking for correctness. I think everybody has done it because we've been working on them. But I do want to add a couple things to our notes before we do number 2 on the AP or the last one on the packet. I think it was number 4. Okay. Now, in the real world, I'm going to draw in pink for a second because I just want to show you. Have you guys seen population of humans over time, like on a graph? And it's very exponential. We're just going to take a trip down memory lane, and I know that these aren't real memories. What year is it? So 2026. And how far back in time do we want to go? So, deal. Year 0. Okay, check it out. Human population does something like this. And I'm going to actually go much slower than that because it started off really slow. And then right about in here, we saw something happen here where it did something like that. And then there's another big dip like here. And then it does this. What happened here? World War happened. Pandemics happened. The Black Death happens. Like, stuff happens. Now, if we think about what's going to happen at the end, is it just going to keep doing this forever? Why? Why would there be a plateau? There's a cap to our population, right? Like, we can probably fit 1 trillion people on this planet, but roughly 990 billion of them are going to die because we don't have food for 1 trillion people, right? There's a capacity to this, which means when we're really modeling stuff, somewhere up here, there must be a line that we just can get close to, but we can never pass because we overcome the carrying capacity. We overcome the cost, whatever the case might be. Now, what we see in this situation is going to be our focus at the start of today, and we are looking at what is known as inhibited and uninhibited growth. So, real exponential models don't increase forever, not in the real world. Something has to give, right? Either we have a very bottom amount or a very top amount. We couldn't get to 0 humans or -2 humans. That doesn't make sense. So we see that there's a minimum as well. Okay, with that in mind, we get to hang out with Isaac Newton here in a couple minutes, and we'll do some cool problems with Newton. But we will just jump right in. Last little tiny piece of 5, right? 5, 6, got me good. Last little piece, inhibited. And I'm going to write these awkwardly spaced for a reason. And uninhibited. Growth/decay. Bless you. Do you guys know what the word inhibit means? So maybe to block. Now, I hope that this doesn't resonate with you like on a real personal level, but I'll tell you the most common place that this is used in like language as humans, with the understanding that you're seniors, and I would not share the same thing with freshmen. When people drink alcohol, they get goofy, right? Like, you guys have seen it. Hopefully none of you have been goofy like that, but you've all seen it. A really common phrase for that is you lose your inhibition. Like, people are more willing to do things when they're feeling goofy like that, whether they should or shouldn't. I'm not speaking to that, but people who are a little buzzed up are more willing to go out and do crazy stuff. Like, obviously, there's a reason that people go to jail when they're... Anyway, not the point. Inhibition means like a limit. You're stopping. So inhibitions, you all have them. There's things that I could ask you to do that you certainly would not do, and you would stop. Like, yes. Now, for this, growth, whether it's decay, growth, exponential, doesn't matter. We have limits here. And we're going to just define these really quickly, and I'm in the wrong section here. And we're just going to look at 2 situations, and then we're going to do a problem with these 2 situations. So check it out. We have the following possible situation. If we have something that's inhibited, it means there's an upper limit that we can't pass. We just aren't allowed to pass that point. So as we're looking at these, and I'm sorry, I'm struggling, so I'm trying to find my notes while I'm talking about this. Here we go. If we look at this, we have inhibited growth in a few situations. If we have the following, and we're going to sneak these in underneath, which is why it's awkwardly spaced. If we have something that looks as dy dx, which there's a rate of change of y, if we want it proportional to y, like we've been doing, but we have an inhibited piece of this, we're just going to have to make sure that we can see where this is. We're going to say that there's some carrying capacity or inhibiting factor, capital M, that will show up in this equation. So this right here is what we see as restrained or inhibited growth. And we'll just say restrained by y equals m. This would be our upper limit. We hold off. We can't get past this upper limit. So it's like our carrying capacity in that problem. Now, on the other side of stuff, we see that we have a lower side of it where we're restrained. We can't go below some value, and we'll do a problem just like that, where we have growth here, restrained, or we have uninhibited, which is the way that we've been doing it. Nothing crazy. Dy dx equals ky, I'm sorry. Where that's what we've been doing. Nothing inhibited. Now, we haven't reached a problem where the Petri dish ran out of space to add to it, but it certainly could happen, right? If I'm growing a population of bacteria, it's going to have an area issue. Now, for these, when we're looking at this situation, we're just going to say restrained here, and we'll make one more little comment. Growth, if we'll say y is less than m, and we'll say it's decay if y is greater than m. Now, this is the same model, everything that we've done, but we're going to do one really cool problem with this. If I have a cup of coffee, which I do have one right now, when I pour the cup of coffee in the morning, any idea how hot coffee comes out of a coffee maker? If I claimed 1,000, would you agree with me? So definitely less than 1,000. Why? Yeah, plus it'd be steam. You couldn't drink it at all, I don't think. We'd have to condense it back down. It's really about 180 is where it comes out of a coffee maker. Like it's burning hot, but it's not boiling hot because you couldn't do it if it were boiling. Now, I've set my cup of coffee. I'll tell you, I poured that out and it was too hot to drink this morning. Do you think I can go over and take a drink of it now comfortably? Now, how warm do you think it is in here, in this room right now, if we had shot in the dark? I'll stick with 68. I'm fine. Actually, 67 we'll go with. Now, yeah, it's not dead. Okay, with that in mind, if it's 67 degrees in here and my coffee was poured like 2.5 hours ago, would it be weird if my coffee were like 40 degrees? Why would that be weird if my coffee were 40 degrees after sitting in this room? Yeah, like, do we all agree that eventually the coldest it can get is going to be pretty close to room temperature? It'd be weird if it got way colder than that. That'd be like laws of thermodynamics are broken, or maybe there's some stuff we can do like heat sinks and things like that where maybe we make use of that. But we can all agree that it's not going to be frozen. It'll be about this room temperature. Cold coffee, same temperature as warm soda. That always has bothered me, just in your head. They are the same temperature. All right, let's do a problem. That didn't seem to blow any of your guys' minds. When I had that realization, it was like earth-shattering for me. Okay. Maybe not really earth-shattering. We're going to do that Newton problem, and specifically we're going to do the cooling problem on that packet. It is entirely up to you if you want it in your notes or if you want it on the worksheet. Don't care either way. Okay, let's take a look at this one. And what we're about to see here, just so you know, is Newton's law of cooling. And Newton had the same realization. If you took a cup of tea, or if you poured a cup of tea and left it out, eventually it cooled down to the room temperature. Do you think it cools down faster to start or faster towards the end? Towards the start. It has more energy to get rid of, so naturally it should get rid of more. It might drop 5 degrees in the first minute after I pour the cup of coffee, and then 5 degrees over the next 2 minutes. Like, it does not go as fast. So we're going to do Newton's problem here and see if we can't pretend like we are going to Cambridge in the 1600s. Okay, here we go. We are told that the following relationship exists, and this is the number 4 on that packet, Newton's law of cooling. And the language is ugly, just so you guys know, but we have this expression, du dt equals k u of t, and I can just call this u if you guys would rather, minus a capital T. All right, right off the bat, does this look like this? Like, very similar. Now, the pieces might be switched around, right? And that's okay. But we can all agree, I think, that it has the same form. Some constant, k, times this difference in here. Okay, now on this problem, we are taking the apple pie out. And I keep using the cup of tea example because there's a lot of tea problems on past AP tests for whatever reason. But here's what we're after. We know that an apple pie is baked and temperature 400. So right off the bat, if we're trying to think about this, I get some points. At time 0, as soon as we take it out of the oven, what's the temperature of that pie? 400. Okay, so we're going to use this point on there. When we take it out, it's at 400 degrees. What else do we know? The room temperature is what? So if we read that one little paragraph on that worksheet, what am I going to label as 70? T. So T, and I'm going to leave some space because I bet we write another thing there, equals 70 degrees Fahrenheit. Okay? Any other information that we can pick out of this? After 20 minutes, the pie was at what temp? 300. Is it safe to eat yet? I like that answer. I was going to call y'all wusses if people just said no right off the bat. But yeah, probably not. Cool. Well, we have all this information. Now what we need to do is find a way to get just U. All right. Here's decision time. Together as a class, or do you want to knock the rest of this out on the boards? Close your eyes. We're just going to vote. That's easy. Okay, if you want to do this as a class, like I write up on the board and you guys write in your notes, hands up. Okay, put them down. You others don't even need to vote. Okay, so check it out. We are doing this as a class. Help me help you. I need to solve this for you. I'm stuck already. I don't want to take the antiderivative yet. So divide by u of t minus t. Can I also multiply by dt? Okay, so let's just do that. And I'm going to start working this way, and I'll switch to this crimson color. So we get du over u of t minus t, and capital and lowercase, super duper important, don't switch them, equals what? K dt. Now I'm going to make I'm going to check something, but your guys' feedback is really important here. Do you want me to just call this u instead of u of t? Okay, I'm okay with that. I think that's a natural change, as long as later when we solve this, we remember it's u of t. It does make it look a little nicer. Okay, so I'm actually going to move that because it made it look kind of more annoying to me, but here it is. Now what? JJ, now give me your suggestion. Let's take the integral. I'll do the right, and I want you guys to do the left. Okay, I'm done. I was about to come wake you up, Sean. You got me good. I thought you were sleeping. That's a good point, Aisha. I am the coolest person you've ever met. I'll make sure Fern knows. My biggest piece of guidance, you're going to try to treat capital T like it's a variable. Is it? It's a constant. It's a constant 70 is what it is. I'm going to give you guys a minute. I'd prefer to hear discussion as you guys are going, unless everybody can just do these integrals like super easy in their heads. Ooh, I heard somebody say natural log. I like that. Do we even have to do u substitution here? So let's pretend I do want to. If I do u substitution, what would we pick as u? Rafa says u minus t. Does anybody else agree with that? And knowing that t is a constant, if I did the derivative of that, you're just going to get 1, right? Because it's just du dt would just be 1 minus 0. Okay, we do not need u substitution. We can jump right in here. The natural log of the absolute value of u minus t. If you want to show u substitution, I'm good with it, but you're going to get the exact same thing. Okay, now we're about to do the fun stuff. Everybody loves logarithms and algebra, right? Good, I'm glad we're on the same page. Okay, looking at this. Well, help me out here. What do you want to do? I do this differently than your book, just so you know. I would like to walk you through the way that I think about this, and then we'll look at what the book does as well. Thoughts on that? Okay, so when we're looking at this, what I think of with this right off the bat is, and I'm just going to see what you guys think of, because I've taught you how to do all this, so I imagine we do think about it the same way. Delilah, what's your thought here? Anybody else look at this and say, oh, it's an E problem? Okay, I'm going to exponentiate both sides or use the definition of the log, whichever way you want to think about it. The left will be only u minus t. And over here, instead of writing e to the kt plus c, is there an easier way we can write that? Ce to the kt. And that's what's been happening the last 2 days. I'm just not doing that integral again. Or I'm not doing the extra algebra. Yay, nay. Okay. Thank you for that, by the way. Now what? How do you do that? Oh my t. Okay. U is equal to ce to the kt plus t. Are we all on the same page here? Okay. Mine has minus, which throws this for a loop for whatever reason. Well, now what? What do you want to plug in? So 400, okay. 70 for t, and 400 for u, because that's my original. And e to the k times what? 0. Love it. I'm going to make a note here, because I didn't do a whole lot, and because we're not using other notation, we're using the fact that we have an ordered pair u of 0, or 0 comma u of 0. Weird. That's the ordered pair that we just used. Well, can we solve this for c? And what do you get? So 400 equals c plus 70. So c must be 330. Do we all agree with that? Now, for this, I'm going to highlight, although I don't know if it really works super well, but we're going to try something new on this. I want to really make this clear that what we've just done is, in this equation, the only thing we didn't have was this value c, and we literally just found it. Like, we have that now. Can we write our true equation for this then? Okay, what is it? And I'm going to switch back to the right notation. We left off the of t part from the beginning, so it was a little bit nicer to write down and look at. We now know that u of t is exactly equal to, what was c? So 330 e to the kt plus what? Plus 70. We're asked to find out when, what? Yeah. Is there anything that we don't know yet that we need? K. Well, if only we had a way to get K. Oh. Rafa, can you say that a little bit louder? Plug in the second ordered pair. I think we can use this ordered pair 20, 300 to get a value for K. This is a calculator problem. Whether I would use my calculator right now or towards the end is entirely up to you. I have no issue typing ugly stuff into the calculator. Can we try to do it? And I should have just held off. Let's try to do it without the calculators and only type one thing into our calculators so that we don't have to carry a bunch of decimals. Okay. What am I plugging in for the U of T? 300. And what did you say, Riley? Where's 60, just out of curiosity? Oh, because you're looking for an hour, right? So I like that. We will do that here in a minute, but we need to get this K value first. So using 300, it equals what? 330 e to the how many t? To the 20t plus 70. Okay. Let's kick through this. And we're going to see that it's not nice, but we don't need to round 10 decimals and write them down every time. We can just do it once. Help me solve. What do you want to do? Okay, so 230. Can I do two steps in one? I'm also going to divide by what? 330. Equals e to the 20t. E to the, whoa, 20k. You're right. I'm sorry. I'm going to erase that and I'm going to make it stand out. This is e to the kt, right? And we had 20 for t. And what's still here? Thank you for the catch, JJ. That was a huge, that just saved the problem. Thank you. Does it feel okay now? All right, now what? I'm going to take the natural log, and I'm going to try to do two lines in one here. I'll take the natural log of both sides. So, I don't know, we can call this 23/33 if you want. We can keep it 230 over 330. Either one's fine. What am I going to divide each side by? One more step. Over 20. There's my K value. Now, I'll tell you, this is a negative, and it is a negative number. That makes sense that it's going to be a negative because we're cooling down. The rate of change should be a negative. Cool. Well, do we now have everything that we need for our true model? Now's the time that once we have this, we can actually get our full ending answer. We're trying to find U of 60 is what Riley suggested a couple minutes ago. Well, let's do it. What's my C value still? 330. Don't like that 3. Don't know why. 330. E to the, and this is gross, but here's K. 230 over 330 over 20. And times what? Times 60. And there's one more little thing that we have to do. Plus 70. Now, here's the big part. And this is why I wanted, the algebra that we did just now, manageable, I hope. The other side of this, which is what we're going to decide if it's manageable or not, is I now want you to type this into your calculator. And we're going to see, whenever you get an answer, I just want you to shout it out. And I'm going to write all the variations of the answers that we get on the board, because I think we're going to get a couple different ones. Yep, so this is KT, right? So I'll go back to this one. All we've done here is K is this, and T is 60, since that's what we plugged in. And I'll even change that color so it's a little bit more clear, Riley, but just to show you, and it'll branch off. Here's the T there, and it's also showing up right there. Cool. Shout answers once you get them. I'm going to write several of them on the board. Okay, just to make sense of this, we started with a pi that was 400 degrees. If you get an answer that's less than 70, there's an issue. We can't make the pi colder than the room that it's sitting in. Can't do it. So something bigger than 0 or bigger than 70, but less than 300. So I heard one. I've heard two answers so far. I heard 181. Is there decimals or is it exactly 181? So we have a claim 181.73. Okay, and what was yours, Abigail? Exactly? Okay. Anybody get a different number? No, if you got a different one, please tell me. Okay. What did you round to? You're okay. Don't get rid of decimals if you have them. Like I would round it, like it'll specify, and I didn't specify. Abigail, you are right now, I don't believe that you're the only person who got it wrong, just so you know. I don't think that that's what happened. But what I do think is that we can check to see where the issue is. Now, the pretty print is super helpful. These calculators are awesome, with the exception of the fact that you have to be so good with parentheses. Would it help if I wrote parentheses around stuff that I'm going to put it typed in with? Okay, well, that'll change it. Did you get the right number the next time? Okay. Do you need me to type this in? Do you want to see me type this in? Is there anybody who wants to see me type this in? Okay. Let me plug this in. I'll do some awkward waiting here. Wrong thing. For real, though, do you guys know what you're doing during elections? Because I have no idea. I don't know. Elections are tomorrow for student council stuff, but I might have said luncheons. I did not mean to if I did. Okay. All right, so this is going to be weird because I have to split it here like this, but I'll share this half of the screen, and we'll just see if I can make it show up here. All right, so a couple ways that we can do this, and it doesn't really matter to me. What I typically do, in case I have to do more calculations, you could certainly type it in here. Can I also type it in here? Like, if I'm going to have to calculate it again, I might as well just type it in so I can say, oh, let's plug in a bunch of different times, and I'm going to use this. So we need 330. Easy. 330 times, how do I get E on this calculator? Diamond X. Okay, so we have E to the. Now, up here, there's a variations of how we can type this. I recognize that when I'm looking up here, all that I see is this times this divided by this. And I don't really have to worry about like parentheses around stuff because multiplication and division are like the same thing. We just have to make sure our logs and things get worked out. So notice it already gave me the exponent. I there have one left parenthesis, and these like I count these as I go. So let's just see. I can type it in exactly as it shows up. The natural log, and it gives me another parenthesis, 220 over 330. I'll close the parenthesis so it knows it's taking the right natural log. And then I either multiply by 60 or divide by 20. Does it matter which one happens first? Not at all. What's more natural for you guys to type first? Divide by 20. Angel, did you have a question? It is definitely 230. That was supposed to be 230 right here. Okay, over 20, and I'm fine with that, times 60. Or if I'm typing into y equals, I should just say times what? So eventually it'll be 60. That's my x, right? Or my t. Can I just call it x right here? Because then I'm going to type in, I'll just do y1 of 60. We'll see if we get the same number. Okay, so there's my whole exponent. Notice, and I'm going to point up here. My ln, is it open and close parentheses for this? My exponent started with an open parenthesis. Does it ever close yet? So what do I have to do? I have to close it. So we'll close it. And then we add on what number? Plus 70. The benefit of this is that I can now look. Is that what I have written? Okay, you do not have to do it in the y equals part. This is just convenient. We're trying to find the temperature after 60 minutes. I'm going to go back home now. How do I ask my calculator to evaluate that function, y1, at 60? I can literally just say y1 of 60. Okay, what if I don't want that answer? 181.726. Okay, let's go a step further. If I wait 5 hours, which is 300 minutes, my coffee should be colder than 181, I think. What do you think it's going to get close to? Well, let's just go 600 minutes. That's 10 hours away. Okay. Does it make sense that it's almost at 70? 10-hour-old cup of coffee is awful. You guys have all seen me, whether you realize it or not, take a drink of coffee that's at least 3,600 minutes old, just because I leave cups and I take drinks of them haphazardly. And now it's exactly at 70, which makes sense if we have a 70-degree room. Okay, welcome to thermodynamics. Feels okay? Feels terrible. Okay, why did I do this problem before number 2 on the AP? If you need to look at it, like, feel free. Because, gosh, I think that it's that y minus m situation on that, isn't it? I want you guys, you have 7 minutes, and we're going to be a chill minute or two, I imagine. 7 minutes, I want you to rework. If you didn't get it right, I want you to work number 2 now that we've done this one. All that I have for you today is at the end of the hour, you're going to hand in your homework and your word problem sheet. And I'm just going to give you a grade for completing them. Cool. I'm going to end the video now. There's no additional homework tonight, so you guys enjoy that. Tomorrow, we'll be seeing the math behind things like windy.com. Cool.